Alright, this is 11.1 in Advanced Geometry, and today we'll be talking about area of a lot of shapes. I know the instructions on this says find the perimeter also, but that'll make this worksheet take way too long, so we just kind of want this to be short and sweet. We're not going to find the perimeter, and even on your homework when they ask you to find the perimeter of these shapes, don't do it. Just find the area. So first they tell us that each one of these shapes is a parallelogram, round to the nearest tenth if necessary. We'll give them all exact right here. So we'll give both exact and approximate if that comes out. How's that sound? So on your cheat sheet, it's got all these area formulas, and here's how we start all these problems. If they want the area of a shape, we start with the formula. Area of a parallelogram equals the base times the height. And base does not necessarily mean bottom. It's all about the height. The height is the imaginary segment, the dashed line that's perpendicular to some side, and the side that it's perpendicular to is the base. So in this particular problem, the base of this parallelogram is 18 and the height is 16. So we will multiply those together in our calculator, and 18 times 16 is 288. We always put a label with these. Since area is square units, right? It's a length times a width, and the label was feet. Our label for area is going to be square feet. So again, we start with the formula for all these shapes. This is a parallelogram again. Area equals base times height, and the base is 20, and the height is 8. So area equals 160 inches squared. And then this guy, it is a parallelogram, but it's more than that. It's a rhombus because all four sides are the same, as you can see by those tick marks, which are kind of hard to see. And we need to remember some stuff about rhombuses and parallelograms, that opposite angles are equal to each other. So if this angle is 60 degrees, then this angle right here has got to be 60 degrees. And why is that helpful? It's because we don't know the height. We do know the base is 24, but we don't know the height. Well, we can find it in this guy right here because we have ourselves a little bitty right triangle, and it just so happens that it's a 30, 60, 90 right triangle. The problem is it looks like we don't know any of the side lengths. Well, we actually do because of the tick marks. If that's 24, this has got to be 24 because it's a rhombus. All four sides are the same. And now this is the hypotenuse of a 30, 60, 90, so I can find the short leg, which would be half as much, which is 12. Then that means the long leg of this is 12 square roots of 3, which is across from the 60. And that is the height of our actual rhombus here. So area equals base times height. Area is going to equal 24, which is my base, and my height is 12 square roots of 3. So that would equal, we can multiply these two numbers together, 288 square roots of 3. That is the exact area of that shape. 288 square roots of 3. Let's round that to the nearest tenth. Also about 498.8. And then the label is inches squared. So let's try that again. This is not a rhombus because we do not have four equal sides. It's a parallelogram. And I need to find the height. Again, I know the base is 30. But I need to find the height, and this is the trick to it. We have a 45-degree angle, and it's a parallelogram, so opposite angles are equal, 45 degrees. And what we know is that this is a 45, 45, 90 right triangle, because if one angle is 90 and one is 45, the other one has to be 45, because they're all supposed to add up to 180. And we know that this is the hypotenuse, which is 15. So to go back and find the leg, you divide by radical 2. And you can't have a radical in the denominator, so we'll rationalize it and get 15 square roots of 2 over 2 for that. So 15 square roots of 2 over 2. So the area will equal the base times the height. The area equals the base of 30 times the height of 15 square roots of 2 over 2. Well, we can multiply these together and just kind of make 30 a fraction. And you could do a little reducing because you have you have a 2 down here and a 15. We could reduce that, a 2 and a 30. You could reduce that because 2 goes into both of these numbers evenly, like one's in the numerator and one's in the denominator. So this would become a 1 and this would become a 15. So you really have 15 times 15 square roots of 2, because we just took half that 30 right there. And then the exact area is 225 square roots of 2, which we can punch that in and get 318.2 approximately. Label would be square feet. Again, they ask for the perimeter and the area. We'll just find the area of a triangle. We've done this before. The formula is area equals 1/2 base times height. The triangle that they're talking about is the shaded in one. So the base of the triangle is just right here in 15. And the height, remember, has to be perpendicular to the base. That would be this guy right here. Well, they give you a little right triangle right here, a 3 blank 5. Well, we know from memorization facts that that's got to be 4. So we can substitute in now. 1/2 times the base of 15 times the height of 4. And you can take half of 4 right now. It doesn't matter what order you multiply them in. You really have 2 times 15, which is 30 centimeters squared because it's an area. So, you just took half of 4, order, do the old commutative property and move stuff around. So when it comes to this triangle right here, we need to find a height first, right? Any one of these sides could be a base. It really doesn't matter. It's all about the height. This is the height. It goes from a vertex perpendicular down, even though it doesn't actually touch the base. That red thing is the height, and this green thing is the base, because this is the side that it's perpendicular to. So the area will equal 1/2 base times height. Write the formula down first. 1/2 times 22 times 16. And then half of 22 is 11. And 11 times 16 is 176 square feet. So here we go. Here's the base, and here's the height. The height is the more important one to find first, I guess I should say. And you know it's the height because it's perpendicular to something right there. It's perpendicular, that's 13. So let's start with the formula, and I'll let you pause the video and substitute in and solve. So since none of these are an even number, you can just take 13 times 9 and get 117, and that's going to be over 2. And then we can not approximate it, but just then say that that is the same thing as 117 divided by 2 as a decimal. It's 58.5 centimeters squared. So it's really nice when one of the base or the heights is an even number because we got a half in there, but not everything comes out nice. Trapezoid. Remember, trapezoid has at least one pair of parallel sides. Those are called the bases. These are the parallel sides in this. Those are the bases. The height is the perpendicular distance between those two. So according to our cheat sheet, here's the formula for area of a trapezoid. It's 1/2 times the height times the quantity of b sub 1 plus b sub 2, where the b stand for the bases. There's two different bases. There's one that is, whatever that says, 18 right there, I think, and one that is 32. Those are our two bases, and the height is the perpendicular segment. That's 16. So let's just substitute in 1/2 times 16 times 32 plus 18. It doesn't matter which one's base 1 and base 2. We just got to add those two together. So do a little cleaning up. Half of 16 is 8, and 32 plus 18 is 50. So I got 8 times 50, which is 400. And the label is square feet. Again, the bases are the parallel sides in a trapezoid, and because of the arrows, you can see that these two guys are parallel to each other. And the height is that perpendicular distance between the two bases, which is this 28. So it's just turned to the side. Don't let it fool you. So we start with the formula. Area equals 1/2 height times b1 plus b2. And now let's sub in what we know. The height is 28. The two bases are 12 and 24. And half of 28 is 14, and 12 plus 24 is 36. So 14 times 36, we can punch that in. 504, and then it is square yards. Why don't you give number 10 a try? Pause the video, give it a shot. And the height is 20, and the two bases are 32 and 50. So hopefully you got 820 square meters for that. A kite or a rhombus? A rhombus has two different formulas depending on what you have. It's got area equals base times height, like we did in the first few problems. It's also got this one, which is the formula for area of a kite, which for some reason I just noticed the formula is not on your cheat sheet. So area of a kite equals 1/2 D1 times D2, where the D stands for diagonals. Because a kite has two different diagonals, that's what they are. But realize they're multiplied together, and then you take half of them. So the area equals 1/2 diagonal 1 times diagonal 2. And realize you need the whole diagonal length. So area equals half of 40 times, you got to add these two together, 56 and 26. Those add together to be, got lost here, 82. And then area, we just punch that in. That's 20 times 82, which is 1640 inches squared. Again, this is actually a rhombus because the diagonals perpendicularly bisect each other. And the area, since we have the diagonals, we'll use the diagonal formula. And 1/2 times this whole diagonal, which is 40, which times this whole diagonal, which is 20. And then you have half of 40, which is 20, times 20 again, is 400 centimeters squared. Why don't you try 13 on your own? Use the formula area equals 1/2 diagonal 1 times diagonal 2. Make sure you're not adding the diagonals together, you're multiplying them. And this is a kite right here. '48's one diagonal and 28's the other, and you should get 672 square feet when you're all done with that one. Now, on the back side, they give you the area of the shape and some ingredients. They want you to find the missing ingredient. Well, you're going to have to assume that that's a trapezoid. They don't really tell you it's a trapezoid, but it appears to be a trapezoid. They should have that marked in the picture. But you start with the formula. Area equals 1/2 times height times base 1 plus base 2. And we substitute in all the things that we know, reading from left to right. I do know the area, it's 164. Now don't worry about that label, you know, the thing that goes in for A is 164. Then I got a 1/2, and height, I do not know that, well it's X, so I guess I can substitute X in. And then the two bases, I do know, it's 12.8 and 20. So I had all the ingredients except for one. Now I could solve. I'm going to get rid of this divide by 2 by multiplying both sides by 2. And that would turn this into a 328 equals X times, adding those together right away, you get 32.8. Right? This was all one term because it's a half times X times that group of parentheses. So it's all good right there. And now to solve for X, we divide both sides by 32.8. And X turns out to be 10. And then the label is feet because this is just the height right here. It's the height, so it's not an area or anything like that. It's just 10 feet. Here, this looks like it is a kite or a rhombus. And they give you the diagonal lengths, sort of. So they really should tell you what this is. This is a rhombus. What a horrible worksheet. So area equals 1/2 diagonal 1 times diagonal 2, and area equals 1/2. One of the diagonals is 20. The other diagonal is these two put together, and you see how that arrow is pointing right to the middle of this? That means to me that just this little guy is X, so that's going to be 2 X's right there because it's X plus X since it's a rhombus, and we got a symmetry line right there. that both of these have to be put together. X plus x is 2x. So that would mean that the area, whoops, I guess I didn't substitute in the area, my bad. Eraser. We do know the area is 340. My bad. I got way too far ahead of myself. So 340 went in for the area, 20 went in for one diagonal, and 2x went in for the other. And then you could get rid of divide by 2 by multiplying by 2, or you could take half of 20 if you wanted to. You could take half of 2. One way or another, you'll get 340 equals 20x, because the 1/2 and the times 2 cancel each other out over here. They're on the same side. And then we could divide by 20, and x equals 17. And then in the next one, it is a kite type looking thing, so we will assume that it's a kite, supposedly. Area formula is 1/2 diagonal 1 times diagonal 2. We do know the area is 247.5. Then equals 1/2. The first diagonal, now they're saying the whole mamma jamma here is x, so that's cool. And then the other diagonal is 22.5. And now I will get rid of this 1/2 by multiplying by 2, because this isn't a nice, neat, even number. So I can't take half of it very easily. I'll just multiply both sides by 2, and that turns out to be 495 equals 22.5x. And then divide by 22.5, and x equals 22. Label is millimeters. Label back here was centimeters. Circle. Find exact and approximate. Very easy to do. All you need to know is the radius. Area equals pi r squared. Hopefully you've heard that formula before. And all you need to know is the radius. The radius right here is 5. So area equals 25 pi. I went ahead and did all that in my head. The radius has to get squared, and it's going to have a pi with it. Then you punch that in your calculator to see what that is approximately. 25 pi, and round to the nearest tenth is about 78.5. So about 78.5 inches squared, because it's an area. So square the radius, stick a pi with it. That's the rule right here. Radius is 10, though, in this dude, because they gave you the whole diameter. So start with the formula. Then square the radius, get 100, and stick a pi with it. And then approximate that. That'd be 314.2 meters squared, approximately. This one, not so easy, because 9.5 is a decimal, but you still start with the formula, and it's the radius, so it's got to get squared. You just go to the calculator and take 9.5 and square it. And don't round that off. That's 90.25. That's nice and exact. Square the radius and stick a pi with it. Then take that number times pi to see what that is approximately. 283.5 inches squared. And then finally here, the radius on this guy, if the diameter is 11, the radius is 5.5. And we will punch that in once we write all this cool stuff down. We're going to square 5.5 and get 30.25. Stick a pi with it. Then take that puppy times pi. And that is approximately 95.0 feet squared. And finally, area of a sector of a circle. See, they've got just this little shaded piece of pie. It's not the whole circle. Well, it's very similar to what we did with arc length, but this is what we'll do. It's going to be x over 360 times pi r squared. Here's the area of the circle, and this is the percent of the circle you're trying to find the area of, where x is that central angles measure, and a is the area of the sector. So we're looking for the area of the sector. Area of the sector equals 45 goes in for x, 360 still there, and then we're going to have times 9 pi, because you square the radius and stick a pi with it, and we just punch that in our calculator. I don't need any exact answers. You first type in 45 divided by 360 and hit equals, and then take that times 9 pi, and about 3.5. The area is about 3.5 square feet. So formula, this is the same problem again, so whoops, let's just make something up here. Let's call this 40 degrees, and let's call this a radius of 2 feet, just for fun, since I accidentally put the same problem twice. Area equals x over 360 times pi r squared is our formula. The area will equal 40 over 360 times 4 pi, because I squared the radius and stuck that pi with it, and then I'll punch that in. 40 divided by 360 equals times 4 pi. I get about 1.4 square feet. And finally here, area equals x over 360 times pi r squared. The entire shaded sector, since this is 20 degrees, is going to be 340 degrees. So we're finding most of the circle's area times 49 pi. Take 340 and divide it by 360. And we're basically finding 94% of the circle, where its area was 49 pi. So we get about 145.4 label of meters squared. The homework for you is the Chapter 11 out of the book, Chapter 11 mid-chapter quiz. There's 20 problems in there. Remember, if they say find the perimeter, you don't have to do those. Just find all the areas of those shapes. The mid-chapter quiz from Chapter 11, problems 1 through 20. Let me know if you have any questions, and have a good one.